All right, let's knock out this review for the Chapter 3 free response questions. So we're going to try to put everything into play that we've learned so far and apply it to some new type problems. A little bit of graphing, some parallel lines, maybe a little bit of slope stuff in here. So let's get after it. So starting out with number 1, find the values of x and y. I have a set of parallel lines. So because of these double arrows right here, I see that I have two parallel lines. The blue line here is going to be my transversal. Couple things that I notice. The first thing that I notice is that this acute angle right here and this obtuse angle over here, they add up to 180. But I cannot write the two expressions added together equals 180 because I have a y and I have an x, and I can't solve one equation with two unknowns. So I'm going to use this 116 here. And when I use vertical angles, this is 116. Play the linear pair game and subtract from 180. I get 64, 64. And remember, whenever you have parallel lines, it's kind of a copy-paste. So I'm going to take these numbers and I'm just going to slide them over and replace them over here. So that's 64, 64, and 116, and 116. Now I can set up two separate equations. I can set up an equation here to get y. 5y subtract 21 is 64. And then I can set up a second equation that 6x plus 32 is really just 116 degrees. And now I just have to use algebra on both of these. So I'm going to add 21 to both sides, and I get 85. And then I divide both sides by 5, and that's going to go in there 17 times, it looks like. Let's go over here and let's knock out x. So I'm going to subtract 32 from both sides. And when I subtract 32, I believe that's 84. 6 goes in there, 1, 4, looks like 14 times. So x equals 14 and y equals 17 should make that picture true. Alright, number 2 is kind of an application problem that stole from another textbook. So let's kind of take a look here. It says you and your family are visiting attractions while on vacation. You and your mom visit a shopping mall. So let's kind of put some points on this grid so we know what we're talking about. So this is just the coordinate plane, and we're going to put 0, 0 right here. So we're only looking at quadrant 1. All right, we're not looking at the other 4 quadrants. So you and your mom visit the shopping mall, which is right here, which would be at 1, 2, 3, 4, 1. That's the shopping mall. And your dad and sister go to the aquarium. So the aquarium is 1, 2, 4, 6, 8, 9. So that's 2, 9 right there. You decide to meet at the intersections of line Q and line P. Alright, so we have line Q right here and line P right here. And you decide you're going to meet at that intersection before heading to the subway. Each unit represents one block. So what are the coordinates of the meeting point? So first of all, the meeting point is right here, which is 1, 2, 3, 1, 2, 3, 4. So it looks like 3, 4 is the meeting spot. Find the equation of line Q using any form. So line Q is the blue line. I have 2 points to choose from, so I'm going to use point slope form. I think it's probably the easiest. I'm going to choose to use this bottom point as my point. So I'm going to do y minus the y coordinate equals x minus the x coordinate, and I need to find slope. So finding slope with those 2 points, 2, 9 and 4, 1, and the order that I write them doesn't really matter. But I'm going to do y to subtract y over x subtract x, being sure to go in the same direction. And I get negative 8 over positive 2, which just shakes out to be negative 4. So there is my slope. And I'm going to just leave it right there in point slope form because it said I could do it using any form. Find the equation of line P. So I'm going to repeat the process. And I have 1 point. I have 3, 4 is definitely on line P. So y minus the y coordinate and x minus the x coordinate. And for slope, I basically I'm going to use this point, and I have to find another point. Looks like, maybe I'll use it right here where the subway is, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, 1, 2, 3, 4, 5, 6. So that's 9, 6. And I could subtract them, or I'm just going to actually use the counting method. I'm going to go up 2, so I have a rise of 2, and a run of 1, 2, 3, 4, 5, 6. So 2 over 6 is really 1/3. So there's the slope for my red line, 1/3. What is the distance from the meeting point to the subway? So this actually goes back to chapter 1. So I need to find the distance from the meeting point to the subway. All right. Well, I'm going to erase a couple. Well, actually, I don't have to erase it. I guess I can kind of use the bottom part. But there's a distance formula. I'm not a big fan of it. I'm going to create a triangle. And when I want to find this distance right here, I'm going to create a right triangle, and I'm going to use Pythagorean Theorem. So this leg of the triangle is 2. The bottom leg is 1, 2, 3, 4, 5, 6. And this is going to be my C. So when I set up the Pythagorean Theorem, I have leg squared plus leg squared equals C squared. So to get C, it's just the square root of 2 squared plus 6 squared, which 2 squared is 4 plus 36. That's the square root of 40, which it's about 6 point something something something. Let me grab a calculator here. Get in a nice, except they want the nearest tenth. So let's do this. Square root of 40. Looking at about 6.3. So the distance from the meeting point to the subway is 6.3 blocks. Alright, moving right down. Are we done, or do we have more? On the line between the shopping mall and the aquarium, is there a meeting point that would be closer to the subway? Alright, so let's talk about this a little bit. This was 6.3. On the line between the shopping mall and the aquarium, so on this blue line that we had there, on that line, is there a meeting point that would be closer to the subway? And the answer is no. I mean, if we want to meet at the subway, this is the closest spot. From here to here, I know this is the closest spot to get there because of this right angle. The shortest distance from any point to any line is the segment that is the 90 degrees. We learned that, I believe, in section 3.4. Any of these other lines I draw as a meeting point would be further. They would be a longer distance because the perpendicular distance is always shortest. So hopefully I did an okay job of explaining that one. Alright, number 3, determine if the two lines graphed on the right are perpendicular. Justify your calculations. So you can't just say, yeah, they look like they are, or no, that they're not. So basically, the question is, how do I prove that lines are perpendicular? Well, we need to figure out their slope. Okay, we need to know that their slopes are opposite reciprocals. So we need to find the slope of these two lines. So let's look at this blue line right here. His slope is up 3, right 2. So the blue line has a slope of 3 over 2. And that's line M1. So line M1 has a slope of 3 over 2. The red line here, this red line, when I look at his slope, it goes, and I'm going from point to point, and I always move from left to right. First of all, I know it's a negative slope because it's decreasing as I move from left to right. And I go down 1, 2, 3, 4. So down 4, 1, 2, 3, 4, 5, over 5. These two slopes are not opposite reciprocals. So the answer is no. They are not perpendicular. Man, they look like it. They look pretty doggone close, but they're not. All right, number 4. This comes out of section 3.4. This was on your quiz that we did earlier, write and solve an inequality for x. And this kind of goes back to that part E in question 2, write and solve an inequality. Well, the fact is that WY, the length of WY, has to be shorter or less than x plus 3 because it's the perpendicular line. That's the shortest distance from a point to a line. The shortest distance is the perpendicular distance. So now we need to solve this inequality. I'm going to subtract an x from both sides, and I get x is less than 3. The only problem is, so x smaller than 3, but I can't go too small, because if this value becomes 0, I don't have a picture anymore. And it definitely can't be negative, because distance or length can never be negative. So I got to solve a second equation and say, hey, when is 2x going to remain positive? And when you divide both sides by 2, you realize x better stay bigger than 0. So I'm going to put this in there and have a compound inequality. As long as x is any number between 0 and 3, we're okay. But it cannot be bigger than 3, and it cannot be smaller than 0. Otherwise, either our picture's gone or our rule about the shortest distance being perpendicular would be violated. All right, number 5. Find the measure of angle YWX. Where's that guy at? So YWX is going to be, so we want to find this little red angle right here. And I think that it wasn't said, and I apologize for this, but I believe we also have to know that these two lines here are parallel to each other. All right, I think we have to have that fact in here. So using that fact for YWX, since this is my transversal, I'm going to use alternate interior angles. That's 114. So this side is 114. And this 114 angle and this little guy are also same side interior. So they have to add up to 180. So when I do 180 subtract 114, correct answer is 66. All right, so the red angle there is 66 degrees. So right in there, 66 degrees. I could do a little vertical angle and get 38. And I also could get this angle because I know triangles add up to 180, but I didn't need to do that, but you could. All right, moving right along. Given points, blah, 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 blah. What type of lines are, so this is just another one where I got to find their slopes. So line AB involves these 2 points. So let's find the slope there. 10 minus 4, 1 minus negative 1. Well, that's 6 over 2, so the blue line has a slope of 3. CD, the red line, is 3 take away 0, and 2 take away 1, which is 3 over 1, which is just 3. So since these lines have the same slope, therefore they must be parallel. Parallel lines always have the same slope. So I didn't even need to draw the picture on the grid. I can just simply use the slope formula. It's the most efficient way. Graph the following equations. So I'm going to graph using the slope-intercept method if I can get away with it. So remember, this one right here is in y equals mx plus b. So I know this back number is my y-intercept. So it crosses right here at 4. And I know the slope is -2, which really means go down 2, right 1. So down 2, right 1, down 2, right 1, down 2, right 1. And you're going to get a line that looks something like that. Number 8, same idea. I cross at -3. This time I have a positive slope, so I'm going to go up 3, right 4, up 3, right 4, up 3, right 4. And connect those guys together. Moving on down. I got y equals 2x. This one's a little bit interesting because you look at it and it doesn't appear to have a y-intercept, but you actually treat that as 0, so it crosses at the origin. And a slope of +2 means I go up 2, right 1, Up 2 right 1, 2 right 1, 2 right 1. The next one, whenever it's y equals and it's missing an x, you know these are going to be a horizontal line. So I like to think about this as you cross the y-axis at -3. So it's a horizontal line, crosses the y-axis at -3. You could also interpret this as y equals 0x minus 3, which the slope of all horizontal lines is 0. Number 11 and 12. 11 is kind of another, not a trick question, but kind of a freak case where you're missing the y. So this is the opposite. You cross the x-axis at 7. So cross the x-axis at 7. Notice that it cannot be expressed in y equal form. There is no y. So when you cannot write it in y equals form, that means that your slope was undefined. So all vertical lines have an undefined slope. Number 12 is interesting because it's in standard form. And I can see two ways to solve this. The easiest way to solve this would be to make a little t-chart and find the two intercepts. So if I let x be 0, if I plug 0 in, that would be 3 times 0 plus 2y equals 12, which is just 2y equals 12. And divide, I get y equals 6. So that's 1 point, 0, 6. If I want to find the x-intercept, where I cross the x-axis, I let y equal 0. And when I put 0 in for y, I get 3x plus 2 times 0 equals 12, which is just 3x equals 12. So x equals 4. So then I plot that point at 4, 0, and I get my line. Now, some other people might do it differently. They might just solve for y, force it into slope-intercept form. So I need to subtract 3x to move it to the other side. And then I need to divide everybody by 2. And when I simplify that, I get -3/2 x plus 6. Now I can use the slope-intercept method. I have the y-intercept, crosses right there. And then the slope of -3/2 means down 3, right 2. So down 3, 1, 2, 3, right 2, and down 3, right 2, down 3, right 2, and you'll get the exact same line. So two different ways to handle that one. Standard form. All right. And I believe, again, I apologize, but I think in order to do these, you had to assume that we had some parallel lines going on. So find WYX. So on this one, we're actually looking for this angle right here. So a couple moves, I think, we can get it. Move number 1 is that this angle is same side interior with this angle. They're both same side interior, so they have to add up to 180. So when I subtract 105 from 180, I get 75. I can play a vertical angle game, and this is 42. And now let me just blow this up because it's getting kind of cramped in there. But I have a 75, I have a 42, and we do know that triangles have to add up to 180. So far, 42 plus 75 is 117, and subtracting from 180, that is going to give me 63 degrees. So I believe that is the answer to our question, 63 degrees. Number 14, we've seen this problem. This is probably the 4th time we've seen this one. It was a bonus, and it was in our notes. It was on our homework. It was actually straight off the ACT. So a couple different ways to do this. The way that I think is the simplest way, or the kind of most clean, is I'm going to add in my own parallel line and split x. Not down the middle, but I'm just going to split x. And I'm going to do two different parts here. So playing a linear pair game, if this is 148, his supplement is going to be 32. And now I know that this angle and this angle are alternate interiors, which makes you 32. And up above, I can play the vertical angle game and get 37. And so then I have another alternate interior. If you're 37, you're 37. And now I can just simply add those two angles up. 37 plus 32 is going to be 69 degrees is going to be what x equals. There's other ways where you can extend one of those V lines out and create a triangle. I think it's a little bit messier, but definitely doable. What do we have next? All right, I believe that's it. So we're at about 20 minutes. So please check out the video. If you have any questions, ask me about it at the beginning of class tomorrow, and then we will be getting started. I'll probably select maybe 8 of these, somewhere around 8 or 10 of these for the last 20 points of our Chapter 3 test. See ya!